Next, we have Cramer's rule. Cramer's rule gives us yet another way to solve a system of equations with 3 equations and 3 variables. It tells us to start by finding the determinant of a 3 by 3 matrix. We'll start by making the 3 by 3 matrix by taking the coefficients of our x terms. This will be our first column. And our coefficients of our y's, that will be our second column. And then our coefficients of our z will be our last column. When we take this determinant of just the regular coefficients of our variables, we'll call that D. Then we want to find 3 other determinants. The 3 other determinants will be the determinants of 3 by 3 matrices created by replacing a column of the matrix we just created with the coefficients that are on the other side of the equal sign. That D1, D2, and D3. So what we'll do is we'll create 3 different determinants. The first one we'll call D with a little x at the bottom, and that one will be created by taking the D1, D2, D3, and just replacing that first column that is normally the x coefficients. Everything else will stay the same. The y coordinates stay the same. The y coefficients stay the same, which is the B1, B2, and B3 on the second column, and the z coefficients on the last column stay the same. Only the x column will actually switch out for just the regular constants. That's why it's called dx. The next one, dy, is going to work very similarly. The x column will stay the same. The z column will stay the same. The only one that's going to get swapped out here is the y column. Is normally the y coefficients is going to get replaced with just the regular constants. Again, this is going to be our dy. So that again means that we're going to take the determinant, and that will be what we consider our dy. dz is going to be the same idea. On dz, we're going to leave the x coefficients alone on the first column. We'll leave the y coefficients alone on the second column. Only the third column, which is normally the z coefficients, will swap with just the regular constants at the end of the equation. We'll find its determinant, and we'll call that dz. Now the question is, what are we going to do with all this? Well, it says that in order to find the answer for the variable x, according to this, what we can do is we can take our dx determinant and divide it by the determinant of that first matrix, just a regular d, and that will give us our value of x. Then next, it says to find the value of y, we can take the determinant of the y, the dy that we got, and divide it by the determinant d that we got from just the regular coefficients, 3 by 3, and that will give us our value for y. That means to get the value for z, we're just going to take the dz determinant and divide it by just the regular d determinant. This will give us what you're always trying to find when you're solving an equation or a system of equations for their variables. We need the values for both x, y, and z. So this is just another way to do that. Because this involves so many determinants, and usually of 3 by 3s, we will not do this many times. So let's try to solve one system of equations using Cramer's rules to solve a system of 3 equations with 3 variables. So first we need to find the determinant of D. So the determinant D should be formed just by the coefficients of the x, y, and z, and should have nothing to do with the actual other side of the equation. So the determinant that we're looking for is the determinant for the matrix 1, 1, 1, 2, -1, 3, 4, 2, -1. We would also want to find the determinant of another 3 by 3 matrix found by replacing that first column of our matrix above with that line of constants. So we'd replace just the first column with those values. We would replace it with the 4, 4, -15. Everything else would be the same. So that'd be the 1, the -1, the 2, the 1, the 3, and the -1. We would also want to find the determinant of another matrix, and we'll call that determinant dy. Again, it will be a 3 by 3, but this time we are going to swap out the second column, the y column. So this time the first column, 1, 2, 4, will stay the same. Only the middle column will swap this time and will again get swapped with that 4, 4, -15. The z column will stay the same as 1, 3, -1. And lastly, we need to find the determinant of a third 3 by 3 matrix, which this time the first two columns would stay the same. Only the z column, the last column, would change. So the first column, 1, 2, 4, would stay. And the middle column, 1, -1, 2, would stay. It's just the last column that would replace the z coefficients with, again, our constants, which is 4, 4, -15. So the hard part with this problem would be that you're finding the determinant of not 1, not 2, not 3, but 4 3 by 3 matrices. Now, if you want to practice this on your own, you can, but let's go ahead and just give you the values of these so that we can actually see how this formula is going to work. The first matrix, D, has a determinant of 17. The second matrix, dx, is going to have a determinant of -68. And the third matrix, dy, will have a determinant of 51. And dz, the determinant of that matrix, is 85. I highly recommend you practice this on your own, and this will give you much needed practice on finding determinants on 3 by 3 matrices. The question is, what do you do with all of these determinants once you have them? Well, the formula says for Cramer's rule that to find your actual value for x, that you take the dx and divide by the determinant d. So, well, dx we found out was -68 divided by the determinant for d, which was 17. Well, -68 divided by 17 would give you -4. So that means our value for x is -4. Now we do the same thing for y. So moving right along, we would say, well, y equals dy over d. So we would divide, well, on top we have that dy was, well, that determinant was 51, divided by, we said the determinant D was 17, so 51 divided by 17 is 3. So what this means is that the value of y for the system of equations is y equals 3. Lastly, we would go after finding z. For z, we have that dz, determinant, divided by d. Well, dz was 85 divided by 17, which was our determinant d. So 85 divided by 17 would be 5. So that gives us a value of 5 for z. That means our final solution using Cramer's rule is x equals -4, y equals 3, and z equals 5. Again, at the beginning of this chapter, we did problems like this using elimination. We've also set up a system of augmented matrices and solved this using row operations by creating reduced row echelon form, which, remember, created a diagonal of 1s, which would tell us that x equals some value, y equals some value, and z equals some value. These are 3 different ways to solve the same type of equations.